Okay, for 9.2, we are developing formulas for circles and regular polygons. The equation is A equals 1/2 AP, where A stands for the apothem, P stands for the perimeter. The apothem is the distance from the center to a side. The center is equidistant from every vertices. For this first problem, to find the area of a regular hexagon with the side length 10 centimeters, there are 3 steps always. The first step is to draw a figure if you don't have one drawn. The second step is to find the measure of a central angle. This is the central area here. If we want the central angle, then we know that a circle makes 360 degrees. So if we take 360 and divide by the number of sides, that will give us the angle for this one piece. So this is a hexagon, which means there are 6 sides. So 360 divided by 6 gives us 60 degrees. So this angle is 60 degrees. Step 2 is we can either use tangent or we could use 30, 60, 90 special right triangles to solve for either the apothem or the side length, depending on what you're missing. In this case, they gave us the length of the side as 10 centimeters. So we have the side, but we don't have the apothem, the distance from the center to a side. So what you do is you take your 60-degree angle and you split it in half into 2 right triangles. So that makes each one 30 degrees. You take the 10 and split it in half so that each of these are 5. You now have your right triangle, so you can apply trigonometry. And you're always going to apply tan. Tan, that was TOA if you remember, is opposite over adjacent. Opposite of 30 degrees, adjacent to 30 degrees. So if we go over here and we look at this 30, opposite of 30 is 5, adjacent to 30 is A, the apothem. So if we put tan of 30 degrees equals 5 opposite over A, adjacent, we could take this tan of 30, put it over 1, cross multiply and divide. When you do that, you get 5 over tan of 30. Now remember that your calculator has to be in degree mode. So you go to mode, make sure it's in degree. Oops, sorry. This one's in degree mode. Okay, once you know that, you can enter that into the calculator, or you could carry it down to the third step, which is plugging into the equation. A equals 1/2 AP. A equals 1/2 our apothem, which is what we just solved for, 5 over tan of 30 degrees, times P, which is the perimeter. So in this regular polygon, remember all sides are equal, so all of these are going to be 10, meaning that that's 10, 20, 30, 40, 50, 60. So the perimeter is 60. Put this into the calculator and you get approximately 259.8 centimeters square. Now for number 7. Number 7 wants us to find the area of a regular polygon. So we're going to start off with the formula. Area equals 1/2 AP. 1/2 the apothem times the perimeter. Step 1. Is it drawn? Yes, it is. So then what we're going to do is take 360 degrees and divide by the number of sides. There are 1, 2, 3, 4, 5, 6, 7, 8. 8 sides. When we do 360 divided by 8, we get 45 degrees. That means that if I draw a triangle right here, that means that this entire angle is 45 degrees. So what we're going to do is, for number 2, we're going to do tan. But we need a triangle first, a right triangle. So we're going to take this 45 and split it in half, making each of these tiny angles 22.5 each. So 45 divided by 2 is 22.5, 22.5. And if you need to redraw your triangle so you can see it, that angle would be 22.5. We don't know the apothem, this distance, but we do know that this distance, the whole thing's 12 here, so that means half of it would be 6. Just like over here. The whole thing was 10, we took half and got 5. Okay, so tan of our angle, 22.5, is going to equal opposite over adjacent. Remember TOA. Opposite over adjacent. Opposite of the angle is 6, adjacent is x. Put that over 1. When you cross multiply, you do 6 times 1 divided by tan of 22.5. So that will look like this. 6 divided by tan of 22.5. Okay, so when you enter that into the calculator, you do 6 divided by tan, 22.5. And we get 14.49. So this equals 14.49. And finally we have step 3, which is plug it into the equation. 1/2 apothem times perimeter. 1/2. The apothem we solved for here, 14.49, times the perimeter. Now the perimeter, we know that this distance is 12, which means all these other distances are going to be 12. So if we take 12 and multiply it times 8, or go 12 plus 12 plus 12 plus 12 plus 12, so forth, you get 96. Okay, if you put all of this into your calculator, you get 695.52. So the area is approximately 695.52 centimeters square. Okay, number 8. For number 8, first step, draw it. It's already drawn. Next step, we're going to take 360 and divide, let me scoot this over. 360 and divide by the number of sides. 1, 2, 3, 4, 5. When you do 360 divided by 5, you get 72 degrees, meaning that this angle is 72 degrees. Step 2, going to take that 72 degrees and split it in half, making each one of these 36 degrees. Alright, if you notice, they gave us the apothem for this one, but we don't know this entire distance. But in order to use trig, we only use a right triangle, so we're going to work with just this piece first. So, we're going to do tan for step 2. Tan of this angle, because we're working with this right triangle, or this one, it doesn't matter, same thing. Tan of 36 degrees is going to equal, now this time, opposite is x, adjacent is 4. So this one's flipped from the other one because we don't know the side. We know the apothem. Put this over 1. This time we're going to multiply 4 times tan of 36 divided by 1. And anything divided by 1, the number stays the same. So it's going to be 4 tan of 36. Okay, so when you enter that into the calculator, 4 tan 36, you get 2.91. So x is equal to 2.91. So that means that this distance right here is 2.91, which means that this distance on this side is 2.91, which means that the entire distance for that side is 5.82 when you add them, which means that this one's 5.82, this one's 5.82, this one's 5.82, and this one's 5.82. Which then leads us to step 3, the equation, 1/2 AP. Alright, so 1/2 the apothem, which in this case, remember that's 4, they gave that to us, times the perimeter, which is 5.82 times 5. When you do that, you get 29.1. When you put 1/2 times 4 times 29.1 into the calculator, you get 58.2. So the area of this regular polygon, in this case pentagon, is going to be approximately 58.2 inches square. Okay, you're going to do the same thing for number 9, but this one's not drawn, so I recommend you draw your hexagon, which is 6 sides, and your apothem is 3. So number 9 is going to be very similar to number 8, except it's going to be a 6-sided figure.